What's up, everybody? How's it going? Hope everybody's doing well today. Happy Sunday. Sunday fun day. Good stuff. We're going to be doing a Dmvpn live stream today. So I'm actually pretty excited about this. We're going to be going through and talking about how Dmvpn works. It's been around for a long time. I've actually covered it quite a few times here on the channel, but I've never actually done a live stream with it where people have, you guys can ask questions and things like that if you have questions regarding Dmvpn, especially for those of you that are studying for anything CCNP related, or you're studying for potentially for CCIE. So yeah, good stuff. Nice, good stuff. All right, well, I am going to first start off with a quick overview of what Dmvpn is and talk about what its goal is when it comes to how it's deployed. I've got several deployments of Dmvpn in production. Quite a few of those deployments are still in production today. So it's one of those things where it's widely understood, widely deployed. It's really stable. That's one of the reasons why a lot of customers like it. So we're going to be taking a look at how it comes into play in the environment and why you choose Dmvpn over some sort of other tunneling technique like Gre Over Ipsec, for example, and things like that. So it's really to help you understand both the design and the implementation pieces. And once we've covered that, we'll dive into a configuration. So we'll get Dmvpn up and running and stuff like that. And then we'll focus on the actual encryption piece of it. Because out of the gate, Dmvpn, for those of you that did not know this, Dmvpn is a routing technique and not actually a encryption mechanism. So unlike Gre Over Ipsec or anything like that, when you're dealing with Dmvpn, it is a routing technique. It's meant to solve the issues that you run into with Gre Over Ipsec implementations and scalability. So, and I've been in many of those environments. As a matter of fact, I've migrated away from several organizations away from the Gre Over Ipsec to Dmvpn for the simple fact that you can templatize the config, make a couple of modifications to some of the syntax, and boom, you have a new branch up and running. And the cool thing about it is you're not limited to any particular direction or anything like that. So the cool thing is, if you want to run Dmvpn, you can run it pretty much over anything. You can run it over internet, you can run it over MPLS, you can run it over 4G LTE. I've run it all in all three, so I've got experience with that and how those come into play. Obviously, 4G being the slower of the three, in most cases, not all the time. You typically run into problems with latency and stuff like that, so you might have to adjust your Eigrp timers accordingly for situations like that. Am I going to do OSPF or Eigrp over Dmvpn? You can do both. I can start with Eigrp and then talk about OSPF. OSPF is not recommended. Matter of fact, there's a handful of things that you would have to do in order to get OSPF working over Dmvpn, so I don't recommend people use OSPF unless you have a constraint where you're doing multiple vendors. So it's doable, but it's not straightforward. So I'll cover that when we get there. Don't forget to do the contiguous and discontiguous topics. Oh, you're on here. Okay. You just have to look at subnetting, man. I've already talked about that. I'm not going to really dive into subnetting. You should know that by now. But okay, cool. Yeah, no worries. Well, I'm actually happy to see you on the stream there, May. Welcome to the stream. So, cool. So we're going to go ahead and start talking about how DMVPN works and its design use cases, because there's how DMVPN works in a lot of cases ties directly into how you would use it. So let's actually do a little bit of whiteboarding here and talk about the details for that. So let me go ahead and bust out a pen tool and go medium. So we're going to keep the demonstrations and stuff like that relatively straightforward and stuff like that. It just definitely needs to be one of those things where you need to, when you're laying out your implementation or you're talking to the customer. So one of the last customers I did this for, it's been about 6-8 months or so, and they moved away from a Gre over Ipsec implementation. So for example, with Gre over Ipsec, let's say we have 2 branches, right, and the HQ is over here. So we'll put HQ here, and then we'll have branch 1, and we'll do branch 2. Something very simple. Well, with Gre over Ipsec, you simply set up a Gre tunnel this way, and then on the tunnel itself, you enable Ipsec, right? It's a pretty straightforward solution. Same thing here. You create a tunnel between these 2 routers, and then you run, Ipsec here, right? And then you can run any routing protocol you want. Then pretty much any LAN segments that are hanging off this guy, and any LAN segments get hanging off this guy, guess what? They get advertised into Eigrp, they get advertised into Eigrp, and then before you know it, HQ is learning, the different subnets from the branches, and everything's great. Everything's happy. Now, that's great in this scenario. There's a couple different things to keep in mind when you're dealing with this. This is a /30, right? This is a /30, right? So when you are looking at that, 2/30, so say 10.0.0.0/30 and 10.0.0.4/30, so on and so forth. Now, when you're dealing with the subnetting, you're dealing with point-to-point, right? Because it's between your device and another device, so it's going to be a point-to-point connection. What is the meaning of tunnel? Gre tunnel, man. Gre. So this will be a, okay, if you didn't realize, it'll be a Gre tunnel, right? This same one here. This will be a Gre tunnel. So when you are trying to build an overlay, and that's really what needs to be understood here, it's an overlay. So what's the difference between an overlay and an underlay? The real difference is when, well, actually, before I get into that, let me talk about, let me finish talking about the Gre or Ipsec piece, because that's really going to be a good, how do I say this? A good transition point. There's a lot of companies using that, or they're just using Ipsec, point-to-point Ipsec between 2 firewalls, for example, and they're doing the communication between the devices. Ipsec, which Ipsec, for those of you that are using that, Ipsec VPNs are strictly unicast communication, right? So there are a number of ways that you can deploy Ipsec, and it works great, right? You can do straight Ipsec with a crypto map on an outside interface between 2 different routers, not do any routing at all between the routers, and you're just passing data inside of Ipsec headers, right? ESP is actually the encapsulating security payload. That's how you're actually taking you're encrypting the data. The clear text data is being encrypted into ciphertext and sent over the internet, or whatever transport you're sending this over. The bigger brother, or the next step in your routing life cycle, if you will, if you're still using Ipsec, a good transition point for customers is to go to Gre over Ipsec, and it works out really, really well. And I've seen a lot of customers use this, and it's one of the very first things. If you're transitioning from just straight Ipsec and you want to make your routing environment that much better and easier to work with, then what do? You go in and you deploy a tunnel. You configure a Gre tunnel between the 2 devices, and then you enable dynamic routing over that tunnel. So you would make sure that your dynamic routing is enabled for this subnet on both sides, and as long as you're using like Eigrp over the tunnel and then Eigrp on your internal routing, let's draw a big, say you got a /16 hanging out here at the HQ, as long as you're enabling Eigrp on all of the subnets that need to be propagated, and you've enabled Eigrp over the tunnels, Eigrp is going to inherently form a dynamic connection over the tunnel, because that one of the things that GRE enables is multicast communication over the tunnel. It's one of the beauties of it. And then you're able to start doing route exchange, right? Now, the one major drawback to this design is that any new site that I want to add to this existing environment, I need to go take whatever config has been put on the HQ side and whatever config has been done on the branch 2 side. I need to basically take that configuration, and there's probably a lot of steps to it. You need to take all of that stuff and you need to replicate it. And a lot of times, the customers that I've worked with, they're doing a crypto map. They're applying that crypto map to an outside interface. They're putting in multiple sequence numbers inside their crypto map and different peer IP. The configuration can get very intensive. As a matter of fact, I worked for a very large retailer for a while, and one of the things that they did for a bunch of remote offices was to tie in Gre over Ipsec on a per location basis on a point-to-point /30. So anytime you wanted to add a new office, we had to go through, it was probably about 15 things that we had to get configured, and we had a laundry list of notepad templates that we would use in order to build this. It became very involved and not very easy to work with. I will get to those specific questions once we get into the actual underlay and overlay. I didn't want to dive too much into how that piece works. Every time I see RRTC, I think it's... That's funny, Thompson. Rob Riker's Tech Channel stream. There we go. Yeah, you got it. Good stuff, man. So there's that piece. So one of the things that I always tell my customers, especially if they're looking at this as a long-term solution, is get away from the static nature of Gre over Ipsec. There's a number of solutions that are better than it, but if you're working with a customer that's really, really small, sub 10, 20 sites, and they're very static, meaning they're not growing at an alarming rate, or anything like that, then that's going to be a good determining factor of whether you go from Gre over Ipsec to Dmvpn, because there's a term that a lot of CCIEs that I'm friends with use. Just because you can doesn't mean you should. And what I mean by that is, in the event that you're in a small environment and they don't grow, like maybe they're adding one site a year, right? So that maybe a couple days worth of work, not that big of a deal, right? You spend a couple days digging into it. But in other scenarios, when you're adding 10 sites a week, that's a lot of overhead, right? That's dedicating one person a week to doing nothing but spinning up sites. That's where maybe moving to Dmvpn, or as my friend May just mentioned, Flex Vpn. So the difference between Flex Vpn and Dmvpn, there's more that is similar between them than there are different. But the main difference between the two, just for ease of understanding, is Dmvpn is going to typically be reliant on Eigrp version 1, where Flex Vpn is going to be relying strictly on Eigrp version 2. So Eigrp version 2 gives you a crap load more options in configuration than what Dmvpn gives you. I plan on covering Flex VPN in another stream, but it's actually really cool what Flex VPN can do. That's the main difference. So that, and you are using auto templates and things like that to configure it. As a matter of fact, if you check on my channel and you look in the playlists portion tab, there's you scroll down to security. There should be some down. You might have to scroll a little bit, but there will be a lot of VPN related content that I've done, and you'll find Flex VPN, and I talk about it in there. So yeah, I've already covered Flex VPN. I'm comfortable with the concept. I just haven't covered it here. It's not on the CCNP blueprint for Encore or an RC, but it is on the CCIE blueprint for the lab. And for anybody that has any interest at all, potentially taking the CCIE Enterprise Infrastructure exam, it's on there. I'm planning on covering it, only for the fact that I'd rather you guys know what it is and walk you guys through a couple of examples than not know anything about Flex VPN and be like a fish out of water. No worries, man. I'm glad to help. So now, how would you transition to this? So there's a couple different ways you can do this. And I'm not going to go through every scenario and every little minor detail. But if you wanted to move to Dmvpn, what would be a good way to do that? Well, let's say, for example, that number one, you're going to want to do a proof of concept or a POC on this. You're going to want to spin it up inside of, GNS3 or E or something along those lines, CML if you're using that, and get Dmvpn up and running. If you've never dealt with it before, this stream is for you. This set of the Dmvpn set of videos I'm going to be doing is going to be for you because it's going to walk you from point A to point Z, the way that I was taught Dmvpn and the way I rolled it out. It's not difficult to follow or understand. Just you need to know all the parts and pieces to it in order for it to glue together. But Dmvpn, I'm gonna go ahead and clear the screen. Dmvpn stands for Dynamic Multipoint VPN. Now, the key thing with Dmvpn is, again, it's a routing solution and not encryption. What is that? Let me expand upon that a minute, again. So it's designed to help you scale your routing, right? But out of the gate, it does not add any encryption to your environment. Where, for example, if you were to do straight IPsec VPN, if you were to do, actually that's a horrible, IPsec VPN, Gre over Ipsec, or there's a couple of, if you were to do static virtual tunnel interfaces, SBTIs, we're going to cover that as well in an upcoming section. I'm actually still working on recording the videos for all that. Thanks, Annis, appreciate it. These are all actual encryption mechanisms where encryption is the main key in order to get that particular solution to work. Because in order for, could you run Gre without IPsec? You can, and it does work. The drawback to it is there's no protection for your data. So if you get a bad actor on the internet that wants to see what you're doing, guess what? They can. So just some things to think about when you're looking at how it rolls out. Where it's kind of a no-brainer to add IPsec to Gre. You won't even be able to get IPsec VPN or SBTI to work unless you have IPsec deployed. Those won't even begin to work unless VPNs are implemented. Well, Dmvpn actually relies on some other things that are not specifically called Dmvpn. Dmvpn is more or less the design and the architecture. Where when you're exactly, so when you're looking at anything going over the internet that's not encrypted, it's clear text, exactly. So Dmvpn relies on a protocol known as Nhrp, or Next Hop Resolution Protocol. Think of Nhrp like a layer 3 address resolution protocol, or ARP. So the idea of ARP, which is technically layer 2, right? ARP, as it's commonly deployed or leveraged in the environment, is a layer 2 mechanism, right? I know the IP address of who it is that I want to talk to, but I don't know their layer 2 MAC address, right? So what do? You send out an ARP broadcast out to everyone in the network, and then in the layer 2 header, you have all broadcasts for the destination MAC address, which means it floods everywhere. In the destination layer 3 header, you have an IP address that you're pointing towards. So when everybody gets that ARP message in, they're going to decapsulate and realize, oh, well, I'm that IP address. So let me go ahead and do an ARP reply back to whoever it is that sent the ARP request, and insert in my response my source MAC address, which is then going to be learned by the switch in its CAM table, the content addressable memory table, and it's going to take and populate MAC to IP binding. So then the switch will know what MAC is located on which port. Then that information is going to get passed back to the original source of the broadcast for the ARP request, and it's going to say, okay, the destination MAC is X. And that's where layer 2 ARP comes into play, right? Everybody that is studying for your CCNA should know how ARP works inside and out before you even begin looking at anything beyond layer 2. If you don't understand ARP, That's the first thing I recommend you lock down and have understood. I know a lot of CCNAs that don't understand ARP or can't really articulate it that well. They get the general idea. Make sure you have that locked down and you understand it. Nhrp is layer 3 ARP, where I shouldn't say it that way. It's analogous or it's similar in a lot of ways, where what you're basically doing here is you're providing a mapping is what you're really doing, and where ARP is mapping a MAC to, actually it's a MAC to an IP, so you know where to send the traffic in a layer 2 environment. Layer 3 ARP is you're mapping a public, or actually, we'll go to public to a private IP. So the concept is actually pretty straightforward. If there's a public IP that I'm reachable via on the internet, then I'm going to need to tie my tunnel's interface IP to that public IP somehow. And that's what Nhrp does. So if I have branch 1, I have branch 2, and I have the HQ, and let's say this is 101.6.6.3. This guy is 202.7.7.4. And this guy here is 61.21.7.3. Well, if I have again, these are all public IPs, right? Pub IPs. If I have the tunnel IP over here of 10.1.1.1/24, and then I have 10.1.1.2/24, and then I have 10.1.1.3/24. What I need to be able to do, no, I wouldn't recommend, because you're not translating anything. It's a binding. I wouldn't refer to it as that, no. If that helps you, maybe, but I wouldn't tie it to that. I refer to it as more of an ARP because you're mapping something to something else. Because you're not actually sending the traffic, you're not natting the tunnel communication into public IP and sending it across. You're just saying, okay, if I'm here on branch 1 and I'm the branch and I want to spin my GRE tunnel up to the HQ, what public IP address do I need to set in my GRE header in order to get from 101.6.6.3 to 61.21.7.3? And that's what you're doing there. It's a mapping. It's not a NAT. So that way here they have communication. Now remember, the communication between these guys, the underlay, yeah, exactly. So you have this communication going back and forth with all of your public communication, right? Now, does this same concept apply to over MPLS or 4G LTE? It does. But in this case here, we're using public internet because that's the more common place that you're going to deploy this scenario. The idea is in the GRE header, you're going to have these public IPs that are going to be used to figure, okay, I've sent traffic out the tunnel. Now, what public IP address am I going to send this traffic to? What is my destination IP address I need to forward this traffic towards? And the internet routing table is going to know how to reach these, right? And that's the really big thing here. That's why you need to map for Nhrp. They have two different terms. You have the NBMA, which ties to your public IP, and then you have the private IP, which is going to be your tunnel interface IP. Those are the two terms that you're going to have to want to remember and how they come into play. So in the event that I am on branch 1, I want to send traffic towards that is true. There's been a lot of videos created for it, but I don't know many people that have run a live stream to answer questions that people might have about it. So it is what it is, man. So when you get a situation where I want to send traffic from branch 1 to the HQ or branch 1 to branch 2, as long as the communication at branch 1 has a way of reaching or knows how to forward the traffic towards branch 2 or the HQ, it's going to be able to send that traffic and route it over the internet. There's got to be some sort of internet communication to get the config up and running, right? That needs to be in play. But that's really, at the end of the day, what it's designed to do. Now, it's not going to be point-to-point tunnels anymore. This is not a point-to-point tunnel, right? This is not point-to-point. I want to just reiterate that a couple times because at the end of the day, it's not point-to-point. This is going to be a shared LAN segment over configured on a tunnel. And you'll notice that they all have the same subnet, right? They're all in the same subnet. So what it actually looks like is more like this. Let me go ahead and get out of the way. You have HQ. You have branch 1. Oh, that's a horrible B. Branch 1. Branch 2. And think of it like this, where Dmvpn is sitting inside of this guy, and you have communication here. And you've got, let's say this is dot 1, this is dot 2, and this is dot 3, right? And this is where this comes into play. So these guys right here all participate in the same LAN segment. And it's really no different than if you had a couple of routers that you were to physically plug into the same physical switch or the same VLAN on a switch. That's really what's happening here. You're all in the same broadcast domain over the tunnel, right? And that's where the beauty of Dmvpn comes in. Now, if I want to add a location, what do I got to do? And this is really the beauty here. I'm going to go ahead, I'm going to add branch 3.4. Let me just draw this a little bit different so that it's easy to discern. Dot 4, and I add him as a LAN segment, or I add him as a Dmvpn spoke. And then I add branch 4.5. He gets added. What if I want to add another HQ location? Maybe I want another hub. Can I do that? 100%. I can come up here and I do HQ again, and then maybe I make this dot 10, or whatever it comes out to be. I normally recommend your hub IPs to be the last IPs in the subnet. And the reason I do that is because then if you're doing branch 1, you're tying it to dot 1, so on and so forth. To me, it just makes it, the subnetting makes it easier to understand. Is this similar to VXLAN? So VXLAN is its goal originally, and I haven't spent a significant amount of time on it, is to be able to bridge layer 2 communication over a layer 3 interconnect. So for example, if I've got a routed infrastructure between my 2 endpoints and I've got PCs connected to them that need to be able to talk to each other, VXLAN will take care of that, because then you're basically advertising MAC addresses. VXLAN is like a layer 2 VPN. So if you're familiar with MPLS layer 2 VPN or something, or L2TPv3, that'll work. But no, not. It's similar in the overlay concept, but what its goal on delivery, its actual end case, is not the same. Your VXLAN is designed to be able to send MAC addresses over a layer 3 infrastructure, where Dmvpn is sending IP addresses over a layer 3 infrastructure. So at the end of the day, they are similar in that respect, but their end state is different. But I actually do plan on talking about VXLAN and Lisp as we go along, because for those of you that are studying for the CCNP right now, that's going to be something that I see a lot of people struggling with, especially with SDA. I have not spent any time on SDA at all, because honestly, there's no way for me to demo it. I can't play with it, and to be honest with you, reading and documentation and watching videos, you only get so far with that. So in the Dmvpn cloud, your diagram represents a collection of the public and private IPs, or is it just private and they route via public IPs? It's actually the latter half. So you have your tunnel IPs are going to be private, and you're going to be mapping those to public IPs to reach other Dmvpn endpoints in your Dmvpn cloud. That is eventually going to drop you onto the remote tunnel interface, which is going to be another private IP. So now, since I've covered all this, I'm going to now transition over to how the underlay versus the overlay work, because that seems, I think will answer a lot of questions. That's one thing that a lot of people seem to have contention, is understanding the concept of underlay versus overlay. So underlay versus overlay. What is the underlay? Your underlay is the internet. or MPLS, or 4G LTE. Any of those, right? What is your overlay? That's going to be your tunnel. The idea is if I am sitting here on branch 1, I've got the HQ sitting over here, and I've got branch 2 sitting over here, and they've got communication to the internet cloud, right? Once they send traffic out here, they don't really care how it gets there. They just need the internet routing to do its job. But if I've got a tunnel 1 here, I got tunnel 1 here. That's supposed to be a 1, by the way. And I've got tunnel 1 here. Yeah, that'll work. This guy is, say, .10. This has got .1. This guy is .2. What I end up doing is I form an overlay to this guy. And I form an overlay to this guy. Right? And that's where the tunnel piece comes into play. You're building an overlay. the physical infrastructure is going to be your underlay. Your logical infrastructure is going to be the tunnel. And that's really where it comes into play. Let me give you another example that might help tie this a little bit better together. So I'm going to have, whoops, that's supposed to be this guy. This guy right here is going to be a hub. This will be hub 1. This will be hub 2 over here. And then what I'm going to do is I'm going to use this provider and this provider as the underlay. So I have my internet circuits coming down here. I have communication here. I have communication here. I have communication here. So this is going to be spoke 1. This will be spoke 2 down here on router 46. And what I'm going to basically be doing, we change the color over to, say, yellow-green. I am going to form tunnels, and I'm going to draw a big green cloud here. I'm going to join these guys to this Dmvpn cloud, like so. And what that's going to allow me to do is I will have .45, I'll have .46, I'll have .16, I'll have .17 when I add a second hub. And what that's going to allow me to do is any of the routing that's happening here, any of the routing that's happening here, and any of the routing that's happening here, I will be able to advertise into some sort of dynamic routing protocol. That could be Eigrp, that could be OSPF, that could be BGP, that could be RIP, it could be static routing. It doesn't really matter. As long as I provide a overlay of some type, which is going to be the tunnel. As long as I provide some sort of overlay, that will give me the ability to advertise that information over Dmvpn. And then we'll be able to reach whatever locations we need to reach based off that operation. And that's really the beauty of how the Dmvpn comes into play. So now, is that specific to Dmvpn? No, it actually is not. And if you notice right here, I've got I've said Dmvpn and Flex Vpn. And as May asked a little bit ago, is there a lot of differences between them? And there really isn't. Flex VPN gives you more flexibility. Flex VPN, flexible VPN, is what it's short for. We can definitely dive into those details when we start getting into how everything works and its day-to-day operations and things like that. So I will be covering Flex VPN in a later set of videos, but for right now, Dmvpn is our main focus. But that's really what we need to understand in terms of the day-to-day. So what I'm going to do is I am actually going to begin the config, and I think that'll help everybody understand the overarching operations of what's happening here. So let's go ahead and dive into the config. We're going to spend the next, I don't know, however long it might take us to get through this. It won't be fast, I can tell you that much. So, but I'm going to walk you through everything. I'm going to start off on router 45. So let me go ahead and clear the screen real quick. And what we need to do as soon as we get started here is we need to verify underlay reachability. That means that if I'm on router 16, we need to troubleshoot any of this that we might have. So if we do a show IP BGP, we should have routes to reach the subnets that we want to communicate with. So now this is internet-based routing. So when we go through and get this communication up and running, we need to make sure that we can ping whatever it is we're trying to reach. So I want to be able to reach 200.21.45. Well, I have 200.21.45 sitting in my routing table. So that means I should be able to ping 200.21.45.45. And I can. That's the very first thing you want to do. You want to be able to do a ping test from here. I'm on router 16, and I'm ping. Whoops. I am ping. I don't know how that happened. Somehow my settings got popped. I send a ping this way, and then it gets disseminated out this direction. However it's routed through this service provider's backbone, I really don't care. Neither do you. And then it gets dropped over here, and then it gets sent up to this guy, and then this guy responds this way. Yes, it will be. So anything that's recorded in the live stream will be recorded, and you'll be able to watch it in the replay. So that's basically how this comes into play. So we have the one hub is communicating with one spoke at this point, and that's really important. Now, I don't care if you're trying to go over internet. I don't care if you're trying to go over MPLS, whether it's layer 3 or layer 2 VPN. I don't care if you're trying to go over 4G LTE. Unless your hubs and spokes can openly communicate with each other through their underlay communication, whatever that might look like, DMVPN will fall flat on its face because the overlay needs to be able to resolve the underlay. It doesn't know what the underlay is. It doesn't care about it. It just needs to be able to get from point A to point B. But now that we've verified that, let me go ahead and take this one step closer, or one step further, and we're going to do a trace route to the same address, but numerically. Again, we don't care how it gets there. We just want to make sure that it has end-to-end reachability. Okay, now that I have that, I'm going to start on the hub side, and then I'm going to go through and get the spoke side working. I'm going to put in the minimal amount of configuration in order for this to work, and then we can get everything up and running from there. It's not terribly difficult to do, but pretty straightforward. I'm not sure if it's a comment or a question, but conceptually DMVPN is like on-demand full mesh VPN. Nhrp component is like DNS, resolves private to public IP, keeps hub. Yeah, I mean, that's a good way of referring to it. Cool, thanks, Dan. So I'm not going to do any crazy debugs right now because I want to keep the config pretty straightforward. The way that we do that is you go to global config. The very first thing you want to do is configure interface, tunnel, and then give it a number. I'm going to create tunnel 1 for the simplicity of it, but you can have multiple tunnels. And we'll, when I actually release the series for this, I'm going to go pretty deep into it, although I already have covered DMVPN pretty well on this channel. I just want to, for me, it's one of those things where I want to cover it even more. Now, I'm going to say the tunnel source is going to be gig 0/1, and the tunnel destination does not exist here. There is no tunnel destination because we're not doing a point-to-point communication. I will type in the tunnel mode is going to be GRE and then multipoint. Now the tunnel should come online, and there the tunnel is up, right? There's no IP address associated to it, but it's there. But I'm going to type in IP address is going to be 10.1.1.16/24. Okay, that piece is done. Now, let me go over to, part of me wants to go over to the spoke and do the exact same config and then prove to you that Nhrp is needed, but I'm pretty sure everybody here is just going to believe me and take me at my word. So I'm just going to keep on going. The first thing you want to type in here is IP Nhrp and do a question mark. There's a lot of commands. Let me go ahead and scoot this up just a little bit so you guys can see everything. I'm not going to lay down what each and every one of these syntax pieces is because a lot of it is more of the operational, but there's a lot of stuff in here that is required. So, for example, the network ID, not required from what I can remember, it's not required, but it's more like if you're going to run more than one DMVPN instance, you need to be able to differentiate between the different instances of DMVPN. Because if you're running multiple tunnels, you might be running multiple instances of DMVPN. So I'm going to type in IP Nhrp network ID, and we're going to just put in here 1. Something simple. We type in IP Nhrp, and to do that mapping that everybody seems to struggle with the concept of public to private and how they get glued together, this is the actual configuration. So we'll type in map, and we can put in the IP address of the destination, but this would be more of a static DMVPN deployment, and we're not going to be doing that. We can type in map multicast and then say dynamic. So we're going to basically say dynamically learn destinations from client registrations on the hub. This is how the on-demand aspect that Dan just so eloquently put actually comes into play. So are there more commands after that? There really are not. So we have those put into play, And if we were to do show run interface tunnel 1 and take a look at the syntax, there's really not a whole lot here, right? We have IP Nhrp map multicast dynamic and IP Nhrp network ID. Now, one of the things that I recommend you do is I recommend throwing some authentication in here. So IP Nhrp authentication, and then we're going to put in here just Cisco 123, something simple. Is there anything beyond that that I need to worry about? At this point, there really isn't, because this is a hub, right? I don't need to put a ton of stuff in here. You're going to put more configuration on the spoke than you will on the hub. That's just the way it is. So I'm going to go ahead and I'm going to do a show IP interface brief. We can see that the tunnel is up. Now I'm going to go back to here, do show run section router, see if I'm running any dynamic routing other than BGP. And I think BGP is the only thing that I'm running currently, and it is. I'm going to go ahead and I'm going to type in router Eigrp1, and I'll type in network of 10.1.1.0, 0.0.0.255. That will get Dmvpn to automatically use Eigrp once the configuration gets kicked off. Now I need to jump over to router 45. Router 45 is going to be our spoke. I'm going to go to global config, interface tunnel 1, and the tunnel interface itself, the number it's been given, is irrelevant. I'm going to type in IP address. Here is going to be 10.1.1.45/24. And I'm going to type in the tunnel source is going to be gig0/0. And then I'm going to type in the tunnel mode will be GRE multipoint. Are you noticing a trend here? The basic stuff right here for Dmvpn. You need to set the tunnel mode appropriately. Now that we have that in play, now we need to go and define who our hub is going to be. So I'm going to type in, there's a couple different ways that you can do this. I am going to use the newer version of the config, which is a single line of config to point to my hub. And I'm going to, when I get router 46 up and running, which will be our other spoke, I'll show you the legacy way of doing it, which is 3 lines of syntax. I'm going to type in IP Nhrp, and the command is nhs, which is our next hop server. What is our next hop server going to do? Think of it like a DNS entry, or think of it like a domain controller, or something significant in the environment that you need to point towards, and you're going to use that as your pointer to wherever you're trying to go. So here we're going to type in the what is the IP address of the next hop server? The next hop server in this particular case, the IP, is going to be the interface of our hub on the tunnel. So 10.1.1.16. And then it's going to ask us, we could hit the enter key and be done, right? That's if we want to do the old way, that's all we'd have to type in. But I'm going to type in NBMA. So what is the public IP of our remote location? In this particular case here, it's going to be 100.2.16.16. I don't know how I typed in 4s there, but that's going to be the public IP that we're going to try to point towards. And lastly, we need to say, use this NBMA mapping for broadcast and multicasts. So we can do that. I'm going to type in multicast. And if we wanted to do clustering, if we want to do prioritization, those are going to be a little bit more advanced. You know, if you've got multiple tunnels set up, you can choose one hub over another and things like that. We're not going to get into that right now. And that's that. The next thing I need to do, again, is going to be the IP Nhrp authentication. In this case here, it's going to be Cisco 123. And if I do show run interface tunnel 1, just double check my config. I need one more thing, and that's going to be the network ID. So IP Nhrp network ID of 1. Okay, now that I have all that squared away, the next thing I want to go do is enable Eigrp on this. So router Eigrp1, network of 10.1.1.0, 0.0.0.255. If I've done everything correctly, I should get an Eigrp adjacency with tunnel 16, or over tunnel 1 with router 16, which I do, which tells me that my Dmvpn configuration was good. So now if I jump out of here and I do a show Dmvpn and I hit the enter key, I see that I have some information here. I have my peer. This is my NBMA address, so the public IP, where I need to point my Dmvpn, where my hub sits, and then the IP address of the tunnel itself on the other side. So in this case here, router 16 is .16. It's up. We're good to go. The attribute is S, which means it's a static implementation. If I was to look at the detail, a lot of the same stuff. It does give you a little bit more information, but beyond that, it's just pretty much the same stuff we've already looked at. Now on router 16, we can see this. This is normally where you're going to run into problems. If you can't get the spoke to show up on the hub with dynamic routing, you probably have something wrong in your Nhrp config. And that's 9 times out of 10 where I found my problems, where I forgot to do something and everything was good to go after I resolved that. So if I do a show Dmvpn, slightly different output. We can see the peer MBMA address. It's a dynamic registration. We can tell that right here, which is dynamic. And then we can see that the tunnel address is .45. The peer MBMA address is .45, and it's been up for about a minute and a half now. If we were to look at DMVPN detail, not a whole lot more to look at right now because there's not a whole lot really going on. But we have a DMVPN spoke up. Now what I'm going to go do is show IP interface brief. I have some internal networks that I can communicate with. Well, actually I don't at the moment. I don't have anything running currently. Not that big of a deal. I can create a loopback and advertise it, which is pretty much the quickest way for me to do a demonstration on that. But I will actually come in and I'll need to get communication up to router 23. Let me see if router 23 is actually online. Why don't I actually even pull it up? Let me go grab him real quick. Let me pull this back up real quick. That's my mistake. Grab him real quick and put him right there. Let me see if he's configured correctly or not. This is iOS XR, by the way, if you guys are familiar with it. And he's not quite set up for it, but I can fix that. Let's ping 10.100.1.16. I should be able to ping it. If not, I can get that fixed, but not the end of the world if I can't get that to work. So I'm going to go back to 16, and what I can do is I can go to global config. Actually, I don't even have the interface configured. So I'm going to go to interface loopback 0, and I'll just type an IP address of 10.100.1.16/24, and then I'll go underneath router Eigrp1 and advertise that network. So 10.100.1.0, we'll do that. And then on router 45, if we come down here and do a show IP route, Eigrp, we'll be learning one prefix over DMVPN, 10.100 network, right? And everybody's happy because we have communication now. If I was to ping 10.1.1.16, I can ping over the tunnel. If I was to ping 10.100.1.16, I should be able to ping that as well, which means I'm riding over the GRE tunnel. So let me prove to you a couple of little things real quick. Let me go on to, let me do this. Let me right click here and go to capture on gig 0/1. Open Wireshark. Oh, okay. So if you guys run into this problem here where you try to do a Wireshark capture in Eve and it doesn't work, and you get this connection abandoned, the simple, quick way to fix that would be to open up PuTTY and plug in the IP address of the host you're trying to connect to. So in this case here would be 10.255.1.130. On port 22, go to SSH and just get this guy right here. You just need the RSA2 thumbprint, the SSH thumbprint. Click on yes to grab it. You don't have to keep that PuTTY session open either. I'm going to right click on this guy again, go to capture on gig 0/1. We're going to tap the Wireshark, and you'll get this little pop-up where it says it's able to connect to it, and you know you're in good shape. Then we can pull up Wireshark, and I can see that I've got Eigrp going back and forth, right? And everybody's happy. So I have GRE going back and forth. Everybody's good to go there. I have Cisco Eigrp working. We know everything is operational there because we have the dynamic tunnel. Now what I'm going to go do is I'm going to pull secure CRT back up, and I will do another ping. And we'll see a bunch of pings going back and forth. Now what you're going to see as you go back and forth here, let me go ahead and just do ICMP. As you're doing this, we have the the ping was sourced from .45 with the destination of .16. But you'll notice that the underlay specifically the overlay, the GRE header, the IP header, and the ICMP header. So just to help you guys understand how this actually works from an encapsulation perspective, when we're looking at this, so we have the outer IP header, IPv4 header, then we have the GRE header, that's a horrible E by the way, then we have the inner IP header, and then we have our payload. That's basically how this is happening. So what we're happening is, this is going to be where this is your public IP addressing right here. That's your public IP addressing. This guy right here is your private IP. This is your encapsulation, right? But you'll notice if you were to look at GRE, you wouldn't see you wouldn't see IPs in GRE. It's just an encapsulation mechanism. Think of GRE like VXLAN, or think of GRE like 802.1q. It's just some sort of way of putting a header in front of the data so that everybody knows how to handle it. And then the IP header goes to right here. And then you have the payload, which is right here, the ICMP ping, right? And that's really the beauty of how this solution comes into play. So that is that. So let me go ahead and I like to show that so you guys can see like there is no encryption here, and I can prove it. So in a situation like this, can we encrypt it? 100% we can. I'm going to talk about that here a little bit down the road once we get the other spoke up and running. Let me go ahead and clear the screen and continue moving forward on our rollout here. Now that we have that going for us, let's go ahead and get router 46 online, because now we have router 45 good to go. So I'm going to go back to 16. I'm going to do a ping to, in this case here, I need to see what IP address I'm dealing with. I need to be able to ping 200.8.46.46.46, and I can ping that IP as well. Let's do a trace route to that as well, just so we know for sure that we can reach it numerically, and we get there 7 hops away. So we're in good shape there. So now I'm going to go back to router 45, and I'm going to do a show run interface tunnel 1. Now what I can do with this configuration here is I can literally just adjust a couple of variables to it. I can copy this config like so. I can grab Notepad, and this is why I like Dmvpn so much. It's 100% templatizable. All I have to do is adjust this IP address, .46, and just verify that gig0/0 is my tunnel source. My tunnel source is going to be gig0/0, so I'm in great shape. I'm going to copy all this data right here, and I'm actually going to go, now that it's copied, I am going to go on router 16. I'm going to debug IP Nhrp. Well, in this case here it's going to be Nhrp. I can never remember which one it is. Nhrp, and I'm going to type in packet, and I'm also going to type in let's see, what other options do I have? I don't want to do detail. Let me just, what about the map command? You're talking about, oh, you want me to do the, oh yeah, that's right. Thanks for the reminder, Matt. I forgot about that. I was going to show you the other syntax. That's right. Thanks for the reminder. Keep me honest there. I like you. Keep me honest. So now in most cases I would not do this in production, just for demonstration purposes. So interface tunnel 1 will do a tunnel source of gig0/0, a tunnel mode of GRE multipoint, an IP address here of 10.1.1.46/24, and that will get the interface is good to go now. And then I'm going to type in the IP Nhrp Authentication Cisco 123, because that's not changing, and then the IP Nhrp. Did you seriously just dab on me? Wow. Okay, that's cool. I like that actually. That's kind of cool. and then I'm going to do the network ID of 1. So we're good to go there. So I'm going to type in the IP, Nhrp, and then the map command. Here, I'm going to type in the IP address of the destination is going to be, let me just pull this down real quick so that I have it available to me on screen, will be 100.2.16.16, and the NBMA address is going to be, I'm sorry, I need a map, 10. Nhrp map. Destination of the address will be 10.1.1.16, and then the NBMA address will be 100.2.16.16, and hit the enter. You can have multiple NBMAs if you want to, and then we're also going to have to specify the Nhrp NHS. In this case here, we can specify 10.1.1.616, and then the NBMA. In this case here will be 100.2.16.16, and we could add more in there if we wanted to, but we're not going to. So it's already been. So you'll notice it's already been added. So do show run interface tunnel 1. We've already added that line. So let's see, we need to do, I believe the other tunnel had multicast in there, and so IP Nhrp. It's been a long time since I've actually, the actual old school config. I don't know anybody that does it anymore. I just do I always use the one-liner. Actually, in this case here, this is a great time to actually leverage the documentation. So let's go do that real quick. If you're not sure what to do, don't sit there and flail. Go look it up. So I'm going to show you guys how to navigate Cisco's website real quick to find this information. So let me go ahead and bring this guy over. So we'll go to support, and then we will go to all products. Actually, no, I should be able to just minimize this a little bit. That is not doing what I want it to do. Oh, here we go. Networking software, iOS and NXOS. And I'm running on 15.6, so I'll grab 15.6 MNT. I'll click on documentation. We'll go to configuration. And let's see if it'll pull it up. It's not showing up here, so we need to go take this a little bit further. So we need to come underneath, is that Dmvpn? Let's see, security. For the data plane. And, oh, that's the wrong one. I need for secure connectivity. Here it is. So under secure connectivity, we have Dmvpn should be right here. So we'll click on Dmvpn configuration guide. And then we'll come over here to click on Dmvpn. And then underneath chapter contents, we need to come down to the spoke configuration. There's a couple different ways that you can do this. So if we were to look at the syntax, you have the IP Nhrp map, where the server is, and this actually scoots over a little bit, 10.0.0.1 is the hub tunnel IP, and then the 172.17 is the public IP. And then, can you add 2 hubs for high availability? You 100% can. And then if you look at, you have the map multicast. That's the command I was missing. So it's the map this to this, and then the map multicast. That's what I was missing. Rather than sit there and fudge my way through the syntax, it's easier just to go look it up sometimes. So we have map, and then we have multicast, and what was the syntax? Was that the public IP or the private IP? The public IP. So let me go back to this. That's my web browser. I do that by default. Map multicast to the NBMA address, which is going to be 100.2.16.16. I could add, well, that's just pretty much as far as it goes. So now that I've got that in play, do show run interface tunnel 1. Everything is in place that needs to be in place now. So now I'll type in router Eigrp1, network of 10.1.1.0, 0.0.0.255. and that should form me a relationship via Dmvpn. Okay, it's trying. Okay, so with the debug is working. Let's see here. Did I miss anything? That is so true when it comes to Cisco documentation. All right, you'll notice I have a problem of some type here with the config. So it's not coming up. Normally I'd have my adjacency relatively quickly, and I don't have that. So 16 is trying to find it, and it says that you could not map. So let me go see what the problem is here. Encapsulation failed. See that? This is why I'm not a fan of that command. I think public IP is because I don't know what you're trying to say there, but we have a problem here. So the problem, and I don't really understand this, what it's trying to tell me here. The debugs are not clear in this particular case, so it's trying to form the adjacency, but it's not able to. So what I need to go over and do on 46 is double check my syntax here, make sure there isn't anything that I missed. I got everything up and running. Did I set the NHS on it? I don't remember if I did that or not. Let me double check my syntax. I did not set my, notice that I didn't set my Nhrp server. IP Nhrp NHS, oh sorry, interface tunnel 1, IP Nhrp at Nhrp server. In this case here, is going to be 10.1.1.16, and now that I've got that in play, hopefully that fixes it, and there it goes. So this is why we do show run interface tunnel 1. I find this syntax model confusing and more difficult to remember. So because we didn't specify our Nhrp server, it was kind of just, you know, out in the wind. It didn't know what to do. Where this syntax model instead, where we have one line where it says, set the Nhrp server to be router 16, this is the public IP, and go ahead and set multicast. This is where those type of things, a singular line gets the job done, right? So this other mechanism is it's just hard to remember. I remember even in the CCIE lab going through them like, I don't know if I'm going to be able to get this to work. So, but that's basically how that comes into play. So if we were to go back to 16, we can see that everything's good to go. I'm going to do an undebug all and do a show Dmvpn. Now I have both of them up and running, right? And everybody's happy. So we're good to go there. So if we do a show IP route, Eigrp, I'm not learning anything. So let's go to 45 and 46. And let's go underneath here. Yeah, one-liners. So we're going to do a router Eigrp1 and type in network of 10.104.0.0/16. I don't think 104 is down there. It's 103. And then we're going to go over to 46, do show IP interface brief here, and then router Eigrp1, network of 10.103.0.0, like so. And on the hub, on 16, we should be learning a bunch of Eigrp routes, which we are. So we've got reachability there. So now that I've got this squared away, let us transition over to another variation of this. Let's talk about the different phases. Okay, now we've got it up and running. Let's talk about the phases. This is actually something that's rather important because when you're trying to understand how Dmvpn works, if you don't understand this concept, it will be difficult to figure out how to deploy Dmvpn. So there's three phases. You have phase 1, which is you have the spoke to spoke communicate, or spoke to hub is all squared away, right? Because this is our current deployment model. Spoke to hub and is good to go. And then we've advertised these I'm sorry, that's not correct. There we go. So we've got hub to spoke communication going. We've advertised these subnets into Eigrp, and we've added a subnet here. This guy right here we've added in, and he's advertised as well. So we have route propagation happening. Now, in a case like this, you'll notice that these routes were advertised to here. These routes were advertised to here. However, if we were to look back on 45 and 46, we shouldn't see any routes. So let's take a quick look at that. If you look on router 45, and I do show, I did put my pin down, Eigrp, I'm only getting 10.101. Anybody have any idea as to why I only have one subnet in my routing table at the spokes? Any ideas? I'll give you guys a second to think about that. We'll see if anybody has an idea. If you don't, that's okay. But for those of you that feel comfortable with understanding Eigrp, this should be pretty easy to spot. But we'll see if anybody knows why. Boom! Split horizon. Exactly. So, any ideas, Dan? Summary route? No, that really won't. Well, yeah, you probably could do that. That's how to solve it, right? But you have to be able to identify it first. And Dan's right; it is a split horizon. So what we can do, we can try that. We'll take Anis's potential solution. We'll go to 16, and then we'll type in interface tunnel 1, and we'll type in the IP summary address for Eigrp 1 is going to be 10.100.0.0, and we'll put in here a /22. All right, we'll give that a shot. Okay. Well, all that's going to do for us is replace the more specific subnet with a summary. Right, and Dan's got the right solution. So what you would do, not that Anis's solution is wrong. It's definitely a doable solution, but when we have a singular tunnel here, would we be able to get reachability to these other locations? No, it doesn't solve that. All it solves, I mean, if we were to put a default route down there, it would solve it, but we would still run into problems with reachability. So if I was to go back to 16 and say no, type in no here and pull that out, let's throw a default route in there and just do the default. Let's see if 45 can reach 46. Ping 10.104.1.45. And it can. If we were to do a trace route to that address, numerically, 10.104. Oh, I'm attached to that guy. No wonder I'm like, yeah, it's working. It's working great. Let's go to 46 and try that same thing. Let's do let's ping 10.104.1.45. And it does work. Let's do a trace route to the same address again and see how we get there. We go 16 to 45. So we can do it that way. But this makes the routing table cleaner. So Anis's example in solution is a valid one, right? We tested it out. I was aware of that one. I don't normally recommend that one unless you have a reason to go do a summary, but because most people like to see the routes. So let's go back to 16, and we're going to now type in, remove this, and we're going to do what Dan's example is talking about. So underneath the tunnel interface, we're going to type in no IP Eigrp split horizon, or the no Eigrp. Interface tunnel 1, no IP split horizon, Eigrp, and 1. That's going to cause the resync to happen. But now we're not going to prevent routes learned in over the tunnel to be advertised back down. So if I was to go now back to 45 and show IP route, guess what? Now we have a whole bunch of Eigrp routes coming across. Can I still reach where I was trying to go before? Let's try it on 46. Let's try that one more time. And we'll go, yeah, we can still reach it. All we're doing is we're basically exposing the routing table. So we're saying, you know what? With split horizon, what ends up happening is the routes these routes here are advertised over the tunnel to this guy, and they're learned by this guy. But split horizon says don't send any routing updates out the same interface you learned them in on. It's to prevent the accidental repropagation of routing information and potentially create a loop. So we have another connection down here to the other router. Well, what we don't do is we don't advertise those routes this way. They're blocked. But we could do a summary and then remove those routes from being advertised, or do it in his suggestion and do a default route across, and we'll still have reachability, right? But this is still phase one. Regardless of how you accomplish it, this is phase one. Whether you do a summary route, whether you advertise the entire routing table, whatever the case might be, regardless of how you approach it, this is phase one communication. Phase one, meaning any communication from the spoke to the hub, or sorry, from spoke to spoke, must travel, actually let me change my color back to green so that you guys know which one it is, must go this direction, and vice versa. So we have bidirectional communication, but it's going through the hub. Not a bad idea. Now, is there restrictions as to what you'll allow to go down the tunnel? So do you have to allow spoke to spoke? No, you don't. If you want to restrict it to just be spoke to hub and hub to spoke, but no spoke to spoke, you can do that. And you can implement ACLs to block the traffic. You know, I recommend using an extended ACL and apply that outbound on the tunnel interface. Or you could do it inbound on the spoke, but I don't recommend allowing the traffic to go all the way down to the spoke to just get blocked. So you can do an extended ACL here, and then set that outbound here out on the tunnel interface, and say if the source is coming from this range, deny it from reaching this destination. So that becomes more complicated, but it's one of those things that you might find useful. However, for those of you that are in an SD-WAN solution, SD-WAN already has something built into that. They call it hub and spoke, because out of the gate with SD-WAN, and I did demonstrate this on my channel, everything is full mesh out of the gate. You don't have to do anything. Where if you want to move this to hub and spoke, there's actually a wizard that walks you through all the steps, and you add what you need to add in there. You create the VPN list and the sites and all that type of stuff, and you determine who's your hub, who's your spoke, and then you have just hub to spoke and spoke to hub communication. There is no spoke to spoke, which makes it really, really easy to get everything up and running. So if you want to lock that down, extended ACL, block the source and destinations from being able to reach each other, everybody's happy. So, Kloss. I know what you mean by that, but not quite the same thing. She's referring to data center fabrics where you have your access or your leaf has to route through the spine, is what she's referring to there. Cool. All right, now let's take a look at the next phase, which is phase 2. Phase 2 is not an Nhrp operation at all. It has nothing to do with Dmvpn. It's just like phase 1. Yes, exactly, aka leaf and spine. When we're talking about phase 2, you do want to allow direct spoke-to-spoke communication. But when you do this, you're basically going in and telling the routers that, hey, I want you to be able to go directly between each other. So let's take a look, and I'm trying to remember the actual syntax for this. It's been a little bit since I've actually looked it up. I don't actually remember the syntax. Let's see if there's a configuration for that. Oh, I see. I got you. So I forget the actual syntax for you need to go and do split horizon. Technically does well. Actually, you know what? Actually, let me roll that back a little bit. So I'm actually a little incorrect now that I'm thinking about it. Let me come back to this. If we go back to our deployment, so that's actually my mistake. It's been a little while since I've explained this. If I want spoke-to-spoke communication, let me go back to the hub, and let me say split horizon, we'll resynchronize, right? If I want phase 1 communication, where I don't want any spoke-to-spoke communication at all, if I go back to 45, and I show IP route, right? If I don't want spoke-to-spoke communication to happen, then the way that it's deployed right now is how I want it. I can optimize that just a little bit by using a summary address. And as I was thinking about, I was like, split horizon, disabling split horizon on the tunnel is phase 2. So phase 2 is split horizon disabled. Where if we want to go and allow communication spoke-to-spoke, we can optimize that a little bit by using a summary route and getting everything up and running. But you run into problems with that sometimes when you want to restrict who's able to talk to each other. Dan's also right on the summary and the stuck inactive or the SIA. I agree with that 100% as well. Same with May's comment as well. Cool. So phase 1 is not allowing any spoke-to-spoke communication. Phase 2 is allowing it, but by disabling split horizon. I didn't say you were wrong, Annis. So the last one we have is phase 3. Phase 3 is an optimization. So we're going to go back to, we're going to get this up and running on the spokes, and then I'll do the hub. So on here, we'll type in interface tunnel 1. This is an Nhrp optimization. So we'll type in, hey, thanks, Cal. Appreciate that, man. We'll type in IP Nhrp, and here on the spoke, we need to use the command redirect. Or no, sorry, this is shortcut. This is shortcut on the spoke. We'll do the same thing on here. Interface tunnel 1, IP Nhrp shortcut. And then on the hub, on 16, we'll type in IP Nhrp redirect. This is going to be how you enable phase 3. So if I go back to 45 and I do show IP route, you'll notice that I don't have any more specific information in here routing wise. And all the times that I've done this deployment, I've always had to make sure on the hub that I've got Nhrp split horizon disabled in order for this to work. So we'll disable split horizon. And what we will allow to basically to happen is, let me come back here to 16 and do a debug IP or debug Nhrp, and we'll just do that. And what I want to do right now on 45 is I want to do a show IP route, and I should have routes from router 46, which I do. And you'll notice that the next top comes in and we're pointing towards 16, right? So, and if we were to, with phase 2, we have basically the initial part of phase 2. So if I go to 46, and let me do this, debug Nhrp and packet, and do this. The next thing I want to go do is on 45, is I want to ping 10.103.1.46, sourcing from loopback 1, right? Now I can ping it, but notice that 16 and 46 immediately lit up. 16 is saying, well, we have a situation here where we want to redirect the communication. So unfortunately, the output here is atrocious. So basically, what ends up happening is we're basically asking, router 45 is asking router 16, hey, can you send me the information that I need to know in order to reach router 46? What do I need to know in order to do that? So right now it says I need to know how to send traffic directly to router 46 instead of sending it to you directly. Router 46 replies and says, yeah, no worries. We're going to go ahead and send you to this guy right here. This is where you want to go. This is how you get there. You're going to go to 200.8.46.46 and get there all day long, and that's where you want to go. So that's basically how that will come into play. And then we have our receiver resolution that everybody knows how to send the traffic to where it's got to go. Router 46 gets an request and says, okay, hey, somebody wants to talk to you directly. What information do I need to give them? So the resolution comes in and says, this is the information that you need to send back to them. Now if I go back over to router 45 and whoops, I don't know how that happened. I come in here to show Dmvpn. What we're going to have is this dynamic tunnel configuration right here, where this dynamic tunnel, it says DT1 and DT2. DT1 is dynamic and it's route installed and next hop override. So we do a show IP route, Eigrp. What we're going to see is that we know how to get to where we got to go. So in order to get to 10.3 on router 46, use this. But here's the thing, it doesn't update the routing table. Show IP ceph, and we want to look for a particular prefix. So 10.103.1.0/24 internal. We are going to use the next hop. We're going to point towards this next hop IP. We're going to point out this guy. We're going to point towards .46 and not .16. So now if I go back to 45, I'm already there. Let's that ping before, it was just a ping. Let's now take this in, and I'm going to do a trace route. Do a trace. Actually, let's do this. Trace. And do numerically. We go directly to router 46. And that's Dmvpn phase 3. So we're, instead of sending the traffic directly to going through the hub, we go directly to the spoke. So let's go to 46 and do this as well. Let's try this one more time. Let's do a trace route. Let's do a show IP route. And we want to connect to 10.104. Let's do 10.104.0. So I'm going to go to trace route to 10.104.0.45, sourcing from loopback 2 numerically. You notice that we have to go through router, and of course we're doing a bunch of updates in Nhrp, so we see that happening. So if we were to scroll up a little bit, you'd see that the trace route does apply here. And if we look on 45, and we look at a show Dmvpn detail, we have an additional tunnel set up in order to reach where we want to go, right? Now we go back to 46 and I do that trace route again, I go directly to router 45. So Nhrp kicks in and says, okay, where is my next hop? It redirects the next hop, but if we look at the routing table, the next hop does not get modified in the routing table. The next hop gets modified in ceph, or in the layer 2, or the forwarding engine. I shouldn't say layer 2 because that's actually the wrong term. It's the forwarding engine, how data is actually sent through the device. So from a control plane perspective, we know we want to get to router 45, but we don't want to go there. We want to get there directly. And the concept, once we have that down, is relatively straightforward, right? And we have everything up and running, and it's working the way that it's expected to. So if we were to do a show IP route, Eigrp, you'd see these Nhrp overrides. The % sign says next hop override, and everybody's happy with that. So we have that going for us. The next thing we want to take a look at is, well, actually that's pretty much it. I'm going to spend a little bit of time going into the next level, which is going to be diving into how, for some reason there's a dog barking in my backyard, the encryption piece. So if we were to pull up Wireshark again, And we see all this stuff coming back and forth. We can see all this ICMP, not a business, going back and forth. All 100% unencrypted, right? I can see all the data going back and forth and stuff like that. So it's definitely one of those things where having encryption is definitely worth having. So let's talk about that. How would we encrypt this? So we talk a little bit about something that you guys are aware of. We go switch my color over to white so it's easier for you guys to see. So encryption is pretty straightforward, especially in this scenario. If I have the encryption set up, normally you're going to have your phase 1 and then you're going to have your phase 2. Phase 1 is going to be your crypto, your ISACamp policy. So your ISACamp policy with your attributes in here, your encryption, your authentication, your group, and your hash, all that type of stuff. And then phase 2 is going to be the actual encryption, right? Which will be your transform set, your ESP, all that good stuff. Well, the way that this is typically done, and the way most people learn it initially, is going to be through the use of a crypto map. Crypto maps are not bad, but they're also not great either. So what does a crypto map do? Think of a crypto map like a mapping agent or a binding agent for a bunch of attributes. So you can have multiple sequence numbers in your crypto map, and each sequence number could be a different peer. So for example, if I do peer 1, I can have the peer, the transform set, the ACL that's going to allow the communication. So I have my ACL and all that type of stuff. And I can do peer 1, transform set 1, and ACL 1, right? And then I can come down here and do crypto map entry 2, so CM2, and I can do the same thing, peer 1, peer 2, TS2, and then ACL2. And they could all be different attributes, right? The phase 1 needs to match, or it should match. You can have multiple ISACamp policies deployed and have different configuration sets depending on how you're trying to connect to other people. But if I wanted to scale this, I'm usually going to have a 1 or 2 maybe. I normally never recommend more than that because then it's just more processing time. But the crypto map, I've had hundreds of crypto maps. So what does this really tie back to? Gre over Ipsec. And this is where the part of it that I don't like comes into play. Now, do you have to use the crypto map? No, you don't. Do I recommend you using the crypto map? Crypto maps are required if you're not going to be tying your crypto to a tunnel. So if you're not tying your crypto to a tunnel and you're just going to be taking the crypto map, whatever its name is, and associating that to an interface, say gig 0/0, right? You tie it to gig 0/0, and then you tie crypto map, whatever the name is. We'll say this is X, crypto map X. You say crypto map X. That turns ISACamp on globally on that particular interface. And then what that's going to allow to happen is in the event that when you route traffic out this interface, what will end up happening is the crypto map, crypto actually happens after natting does. So if you're doing NAT, you'd have to make sure to deny anything that needs to be natted. Deny anything that needs to be encrypted from being natted. So that in and of itself throws people through a loop. And I don't recommend people do it that way, but it can be done. I had to learn how to do that a few years ago for deployment, and I remember sitting down. I went to my boss, who was a multi-time CCIE, and I said, hey man, I had this problem, and I don't know how to solve it because I've never used it before. I've always tied my encryption to a tunnel, and I've always been in good shape there. But this particular customer has a lot of site-to-site VPNs. They need to do VPN and internet on the same device. And he's like, okay. So we sat down, and that's when I realized, well, we'd have to deny entries in our NAT statements for anything that would be encrypted. And it became kind of a nightmare scenario. I got through it. It was just a lot of config. Lots and lots of configuration. Now, the Gre over Ipsec, what you would do is then you would have your tunnels in the ACL, you have two different mechanisms, or two different ways to configure your ACL. The first way is going to be for LAN-to-LAN communication. So your typical crypto map-based VPN. You're going to have the source subnet and your destination subnet laid out in an ACL and an extended ACL. So permit IP, whatever your source is to whatever your destination is. And on the remote end, you'd flip-flop the source and destination because they would be flip-flopped, right? And then this would be your ACL, right? This would get tied to here. The other variation, if you're doing not tunnel-based encryption, if you're doing tunnel-based encryption, so the second variation, so this will be, I'll say tunnel-based here, and you're doing Gre over Ipsec with a crypto map, you would actually have to come in and you would say the source tunnel IP to destination tunnel IP. So you would basically say 10.0.0.1 to 10.0.0.2. So router 1 to router 2, those would be the IPs, and that Gre would be able to communicate back and forth that way. It's very, very ugly. I don't recommend people do this, but if you're transitioning and you don't want to get rid of your crypto map solution and you want to keep using it, you can do this. Again, it's ugly. It gets the job done, but it's, in my opinion, it's not very clean. It's not a very smart way to go. So how do we transition away from this? Because I want to talk about what a lot of people are going to see when they're doing straight IPsec or maybe Gre over Ipsec, something along those lines, or Ipsec IPv4. A simple way to do this, I'm going to go ahead and clear my screen. A simple way to do this is you're still going to have phase 1. Phase 1 does not go away no matter how you want to cut it. If you do phase 1, you're still going to have your ISACAMP, I can't write, ISACAMP policy. The next one you're going to want to do is same thing with phase 2. You're going to create your transform set, but you don't need to create an ACL. You don't need to match on anything. The next thing you need in the phase 2 portion is create your IPsec profile. The profile is then going to call the transform set. Then what you do with the profile is, so the profile will call the transform set. We'll say this is TS1. TS1 gets called from the profile, and then underneath tunnel 1, you basically protect traffic that's riding over the tunnel based off of routing with IPsec profile 1. That's basically where it comes into play. So you're still tying encryption to it, but you're not calling an ACL to determine whether or not the traffic can be encrypted. And the cool thing about it is when you get into anything that's tunnel-based, whether it's Gre over Ipsec, whether it's Dmvpn, whether it's Flex Vpn, whether it's SVTI, whether it's DVTI if you're doing Flex VPN, whatever your flavor of VPN that you're trying to deploy, these are the things that really make it shine in terms of its day-to-day operations. So what we're going to go do is I'm going to walk you through the syntax of how to get the VPN up and running on the hub. Then I'll map it to the tunnel, and then I will watch it fail, right? That the spokes will fail because then they won't be able to, they're not going to be running encryption. And then what I'll do is I will circle back and configure the spokes as well, and then we'll retest the data plane to show you the difference between unencrypted data versus encrypted data. So pretty straightforward stuff. Let's go ahead and dive into that config real quick. If you have any questions, let me know in the comments and I will do my best to answer them. So we're going to go scroll back up. I'm going to start on the hub. So router 16, I'm going to do an undebug all just to make sure that nothing is going to pop up on me. First thing we need to do is a crypto ISACAMP, and we're going to say a policy. I'm going to call this policy 1. We'll type in the authentication is going to be a pre-shared key. The encryption will be AES. The group will be 5. And then the hash will be, I'm going to use SHA-256 because I can. And that's basically that. So next thing I'm going to do is create the pre-shared key. So we'll type in crypto ISACAMP and we need to specify a key. And I'm going to type in Cisco 123. Now in a DMVPN deployment, one of the things that I definitely recommend you do is, especially in the hub, is leave your stuff just a little bit open. I don't recommend, especially in a very large deployment, where in the addressing portion of the crypto, where you would have one line, a single line per spoke that you want to allow to peer with you. So you could come in here and do address and do 200.21.45.45. Pardon me. That is a viable solution, and then do a do that. That would work. But if you've got hundreds and hundreds of spokes, that means that you're going to have hundreds and hundreds of this single line for every spoke that you're going to add. Small deployment, probably not that big of a deal. Or maybe it's once you've gotten it in, not that big of a deal. But then what happens if your spoke is using DHCP, right? Your spoke is using let's say a residential internet connection, and the IP address that you're tying it to isn't static. This is where that becomes very troublesome. And a lot of environments that I've worked in, a lot of DHCP internet-based communication. So, in other words, DHCP has been handing out public IPs to your endpoints that are going to be terminating a DMVPN tunnel. I don't recommend hard coding an IP. I recommend saying you don't care where the traffic is coming from. You're just going to allow it to come through. And that's all I'm going to do in there, because it makes it really, really easy to work with. If you're going to be doing DMVPN Phase 3, so spoke-to-spoke on-demand tunnels, this is also going to be applicable here as well. I don't recommend people do hard coding. Some people are against that, and they throw them in there anyway, and just a recommendation. So now that we have that in play, the next thing for us to go do is create our crypto profile. So we'll say our transform set. So crypto, IPsec, and then transform set. We'll come in here, I'll call this tset 1, or call it tset, and then I'll specify the variable. So I'm going to use ESP AES, and I'm going to use I'll use 192, so something a little bit unique. And then for the authentication component or the integrity aspect of it, I'm going to go ahead and use ESP SHA-256 HMAC. Because I know the routers all support these capabilities, I'll be in good shape, and that's what I'm going to use. So pretty strong encryption for a lab, but just to show you that it can be done that way. So that we have now done. So the next thing for us to go do is create our profile. So crypto IPsec profile. I'm just going to call it profile something simple. And then underneath here, you would set the transform set to tset, and that's it. And your configuration is done. So do show run section crypto, just so you guys can see it all. So we have our phase 1 portion of it, the ISACAM policy, and we have our pre-shared key defined. We have our transform set to ESP 192, ESP AES 192, excuse me, and then SHA-256 HMAC, and then we have our crypto profile, which calls the transform set. The next thing we're going to go do is interface tunnel 1 and type in crypto IPsec, tunnel protection IPsec profile, and then the name of the profile. Now that's going to enable ISACAMP, and it's also going to bring down our Eigrp adjacencies. And there we go. Now you might see some detail. Let me go ahead and jump out of the way real quick. You'll see some of these details right here. Let's scoot this over here. You'll see this, where you'll see received not an IPsec packet in the VRF inbound. So in this case here, it's going to be I don't have any VRFs configured, so this is just in the global routing table. From router 46, a protocol 47. That basically means that, let me go ahead and scoot this up just so you guys can see it while I'm talking about it. That just simply means that router 46, or whoever the spoke is in this particular case, is still running a straight GRE tunnel. He's not doing anything in terms of encryption. So we're receiving it. Protocol 47 is GRE. Protocol 50 is IPsec. Protocol 51 is the authentication header. So what I need to go do is I need to go take all this syntax right here and copy it. Whoops. Copy it into 45 and 46. So at the same point in time, I am going to have this guy up, and I'm going to say or Ipsec. Oh, well, it won't let me tab it. So KMP or ESP. So we're going to see a lot of that data going back and forth. Let me bring this down just a little bit so you guys can see this all. So we see a lot of Ipsec going back and forth, but not a lot of any communication. So identity protections kicking in. So what I'm going to do is on 46, we'll do 46 first. We'll go to global config. I'll paste that config in. And on 16, let me do a debug crypto Ipsec and debug crypto IPsec. So we're going to see a bunch of stuff happen here in just a couple seconds. So on 46, I'm going to type in interface tunnel 1. Tunnel protection is IPsec profile. That'll turn IPsec on. And there we go. So we see a lot of information going back and forth. And we'll do the exact same thing at 45. So we'll paste that in. And then interface tunnel 1. Tunnel protection is IPsec profile. And there we go. So now that I've got that in play, now you see my Eigrp adjacency is back up. And I actually really like doing this demonstration this way because it really proves that everything is working the way we say it is. Now you see all that communication going back and forth between 16 and 45 and 16 and 46. It's all ESP. It's all encrypted. So if we do a show IP route, Eigrp, guess what? We still have our routes in our routing table, right? If I was to do a trace route to 10.103.0.46, sourcing from loopback 1, numerically, I go through 16, and then what we'll see, actually let me go ahead and, yeah, that'll be fine. And then do that one more time, and then we go directly between the two. And we can see that that communication is 100% encrypted. So if we go to 45, we do a show crypto Ipsec SA. We can see active tunnels up. We have two tunnels actually. We have a tunnel from us to router 16, and then we have a tunnel from us to router 46, and vice versa, right? 16 and to us, right? So we have bidirectional communication going on. If we do a show crypto IPsec SA, pipe include PKTS and peer, we're going to see that we have communication up and running and everybody's happy, right? And that's really what you want to have in terms of the day-to-day. If I go to router 46 and I do an undebug all, let me just scoot to the top here real quick and run through what we are seeing. There's a lot of configuration output, or I should say debug output, because we just spun up 2 VPNs. But I also want you to understand that when you're looking at a scenario like this, that there's a lot of things going on here. Just imagine if you had 200 or 300 spokes and this router just got rebooted. That potentially could be a problem if you were to play around with it and dive into the details. But as you can see, there's a lot going on. I'm not going to break down everything, but I will do a show crypto Ipsec SA. We have our connections up and running. We'll do a show crypto IPsec SA, pipe include peer and PKTS for packets. We can see communication going back and forth between the two. And lastly, we'll do an undebug all here as well. And we'll do a show crypto ISA essay. And then an IPsec essay, pipe include PKTS and peer. And we have all that going for us. So we're in pretty good shape overall. So we know what's going on. We have everything communicating the way that we need it to, and we're doing well. That really, in and of itself, ladies and gentlemen, is Dmvpn. There's not much more to cover than that. There's just there are optimizations. So the next steps for you would be to go and dive into dual hub, and then so you have a single tunnel. So let's actually break this down real quick just so you guys understand what I'm talking about. So right now we have one tunnel. My handwriting is atrocious. One tunnel, which is one hub, two spokes. You're right, Dan. It doesn't work on the ASAs, which is unfortunate. But to that point, what you can do is you can transition from Dmvpn to Flex Vpn. So use Eigrp version 2 instead of Eigrp version 1. Start learning the auto templates and all that type of stuff, the DVTIs, the dynamic virtual tunnel interfaces, and then you can deploy Eigrp v2 on an ASA and have the ASA as a spoke to your Flex VPN deployment. So you won't really take advantage of all the on-demand stuff that Flex VPN supports on an ASA, but it will get you at least to that point. But yeah, I ran into that same problem too. So we have that. Then you have one tunnel, and you have two hub, and then you have 2+ spokes. Then you have two tunnel, one hub, 2+ spokes. Then you have two tunnel, two hub, 2+ spokes. Then you can have two tunnel. Then you can have 2+ hub, and you could also do a multiple data centers. So you can do, say, DC1 and DC2, or maybe you have HQ and you have your disaster recovery site set up, and then you can have 2+ spokes. And then you can get into, this is when you get into this level here, these bottom ones, these are much more advanced scenarios. This is where you would enable the clustering and then the priority at the tunnel level when you're spinning up an Nhrp, so you can pick and choose which way you're going to go with that. So it does give you some flexibility in terms of the operations. So hey, I appreciate that, man. I really do. Thanks, Anis. But these are some of the capabilities. I will be doing demos on all of these variations. Work has been super busy lately, so I haven't had a whole lot of time to record any of the content for CCNP Enterprise, but I am going to keep continuing to work on that until it's 100% done. So if you guys have any questions in terms of any of that type of stuff, you want to see a particular variation done, please let me know, and I will do my best to accommodate. But that is basically how this all dials in. So that's that. Again, there's not much more to Dmvpn than I've already covered. An hour and 45 minutes in, and I've covered pretty much everything you need to know. Now it's just a matter of you spinning it up and playing around with it. So you've seen both variations for the spoke. You've seen the hub config. You've seen the crypto, all the different phases. So yeah, that's pretty much that. So anyway, I'm at almost 2 hours. I'm going to... side note, have you configured ASA cluster using Nexus? Not using Nexus, no. I've only used... let's see. I've done it with iOS-based switches, and that's it so far. I haven't done clustering on ASA yet. That's something I plan on doing though. So yeah, at some point in the future I will, but next I'll have to take a look at doing it with Nexus. That'd be something cool to do. Is it possible to use PKI-based authentication instead of using a parachute? Yes, it is. You can do that. That is possible, but then everybody would have to use. So every one of your nodes in your DMVPN deployment would have to use a certificate. So that is 100% possible. Everything would have to go to a PKI-based deployment, but it is doable. It's been 2 hours of teaching. If you're not feeling tired, would you mind? Oh, not today. Sorry. My 2-hour limit has come up. It's not that I can't. Not that I won't. It's been a little while since I've dove into it, so I don't really feel comfortable diving into and trying to explain all the nuances to it, because honestly, I don't know them. I'm still learning Flex VPN, to be honest with you. So I will do some demos of that, and then I will, maybe in a couple of weeks, I will do Flex VPN as a live stream and see how that plays out, do some basics to it. But it's way more involved than DMVPN. No, you didn't miss all the fun. I mean, I go live 2 p.m. Central Standard Time every Sunday. That's been kind of my thing lately. So if you guys want to see something, let me know. Yeah, if you do me a favor, if you were to, you're better off trying to tweet me. So find me on Twitter at Eigrp. So I'll go ahead and give you my Twitter handle. It's at Eigrp. I know May is already a follower. I think I follow May back. So if there's something you want to see covered in a live stream, you're better off asking there or commenting. Ask there, because then I can take requests then, because I usually don't post a live stream link until Saturday. So yes, exactly. I thank you to you as well. How do I get DDoS API? I have no idea what you're even talking about. I'm not even sure what that is. Cool, guys. Well, hey, thanks for stopping by. Thanks for hanging out with me today. It was a lot of fun. I really enjoyed it. I will be... you are indeed, May. I do appreciate it. So, I am going to go ahead and kill the stream now. You guys have a nice week. For those of you that celebrate and whatnot for the holidays, happy Thanksgiving to all of you that celebrate. I will definitely be enjoying some turkey and Turkey Day and taking some time off from work, as it has been extraordinarily busy for me. Hey man, I appreciate you stopping by, Dan. I really do. It's good to see you. I will. I'm gonna try to keep the live streams going every week. It seems like it's a really big thing now, stuff like that. So, yeah, no worries, guys. If there's something that you guys want to see in the live stream, send me a message on Twitter, because the likelihood of me seeing a comment on YouTube is pretty unlikely, because I get a lot of comments and sometimes they just slip through the cracks. So if you want to see something, tag me in Twitter. I check Twitter on a pretty regular basis. I'm trying to grow my Twitter base, and I'm getting close. What am I at now? I am on almost 1,500 followers on Twitter, and I keep track of that pretty closely. So thank you to everyone that liked my tweet and retweeted my tweet. I do appreciate that. So I will see all of you on next week, Sunday, unless there's something else that pops up. Send me messages on Twitter if you want to see something specific. But other than that, you guys have a nice week. Enjoy the rest of your weekend. Peace out. Take it easy. Stay safe. Thanks for stopping by. I'm signing out now, or I'll keep on babbling.